Okay, so continuing on with class 14, here's the first example of the three examples. I take 25 KSI and 15 KSI, both in tension, and I'm going to use 1030 hot rolled steel. I look up 1030 hot rolled steel in table A20 in the back. Might as well do it. We got the book right here sitting on my lap. It's a good thing to take a look at. And so here we go. We said 1030 hot rolled. We have 37.5. I could have picked an easier one. Maybe I should have picked 30. Like, isn't that nicer, 30 and then 37.5? But anyway, that's the yield strength in KSI. All right, so here is the stress element. Good idea to plot that out. Good to draw this thing out to kind of, when they give us numbers, but like, let's write this down. And I'm at KSI, and this is 15 KSI. And if we're going to do the Mohr circle of this fun guy right here, what you're going to end up with is, let's see, I didn't do a very good job of that. It's okay. I don't know how big I want to make these things. Let's go. Here's 5, 10, 15, 20, 25. Good, right? So here's 25 right there. And here's 5, 10, 15. Here's 15 right there. So we got ourselves a Mohr circle. And it's a pretty small circle, but let's get this thing in here. I don't know what that is. Okay. I need to make my lead just a little shorter. There you go. This is not a great compass. I complain about my compasses all the time. Well, come on. Push that guy down and bring that around. Oh, I'm not having a very good compass day. Whoa. Okay, come on. Oh, that was painful. All right, so the center of this right here, right, is going to be, well, I should say, I'm sorry, the center is already kind of known, but the center of this is should be 12.5, right? In fact, we should have the tau abs max, right? So this one is equal to sigma A, and this one's equal to sigma B. This one's also going to be sigma 1. This is also equal to sigma 2. Sigma 3 is 0, right? So here's sigma A, here's sigma B, right? And there was the other one right there. And if we wanted to graphically put this out right here, we'd go, if this is 5, 10, so this is our 12.5 right here. Right? So here's our big Mohr circle. And then our smaller Mohr circle, other Mohr circle right here. So here's the 3 Mohr circles. Right in there. And we're going to predict that our abs max is right there, which is equal to, as you'll recall, sigma 1 minus sigma 3 divided by 2, which is just 25 minus 0 divided by 2, or 12.5 KSI. All right, pretty simple stuff. Do I need anything else? No. Well, we want to get the safety factor now. All right, so we know that the yield strength, I meant to write this down, 37.5 KSI. So our safety factor, or so let's say that the shear yield is going to be yield strength divided by 2, or 37.5 divided by 2. And I could just look at it. I have it all written out right here, so I might as well just look it up instead of, if I can find the right one. There you go. What we end up finding is this. We have 1.50, right? That's our safety. Oh, I'm sorry. I did not write it out. That's not 1.50. What's 37.5 divided by 2? 37.5, 2 divided, and we get 18.75. Most people should be able to do that in their heads if they have a PhD, right? But not me, no. So the maximum shear stress theory takes the shear yield strength and divides by the abs max. So we got 18.75 divided by 12.5, and that's 1.50. All right, so there you go. There is our safety factor. But let's take a look at this on the, so that was problem 5.3. But let's take a look at this on the failure loci. I could call it the stress loci. The failure loci would be a better name. That's what they like to call it. So I need to fix that, but it's okay. So we're on a failure loci. So we want to try our best to plot this out, and then and we're doing it by hand right here, right? So I'm gonna split this thing in half. And did I already figure out what the best increment was going to be? I think I decided to go by tens. But they're here, 10, 20, 30, 35, 37.5 right there. So 10, 30, 10, 20, 30, 35, 37.5, 10, 20, 30, 35, 37.5, 10, 20, 30, 35, 37.5, right? So we will plot the thing out. And I forgot to point out some features of these things, of these failure loci. Now I'm going to call them the right things, right? They are symmetric down this axis right here. So we don't actually use anything over onto this side, but it does make it look pretty that it has this nice symmetry to it. Right? And we know that this is 37.5 right here and 37.5, right? And so already we have 25 and 15 are our sigma A and sigma B. So we have 25, so here's right here, and there's 15 is right there, right? So we can actually come up to right there at that point, and we will draw a line as best we can, trying to be careful not to. There you go. And I call this O, A, and B, right? And so I think I'm going to use my millimeters right here. I have millimeters, and try my very best to be accurate. Let's see. And I think, of course, these are centimeters, so I'm going to say that this is 20 right here. And we can count backwards, and that looks like 28, right? So we can say that OA is equal to 28 millimeters. And then we could do the same thing for B right here, and that looks to be, here's 41, 42, it's close. OB is 42 millimeters, and let's say approximately, there you go, I'll turn those into approximately. So my maximum shear stress theory says that it's OB, this distance, divided by OA, or 42 divided by 28. And so what are we going to get? 42 and 28. I get 1.50 exactly. Wow. That's pretty amazing. All right. Well, that's what this thing is for. So we're going to do, this is example 1. We're going to do a separate video for example 2. So check that one out. I like to keep them short when I can remember to keep them short. So this is only a 9-minute video. But you want to see more examples, this is example 1. You'll see example 2 in the next video, which is really, really exciting. So see you then.